Finding derivative using chain rule. When we have a function which is itself a composite function like f of gx, which we may say that it is f of u, where u is another function gx. And how are we going to find the derivative of such a function? The derivative of y in this case is going to be the derivative of u, derivative of f in terms of u times derivative of u, which may also be expressed as derivative of f in terms of gx times the derivative of gx. Let's try to understand this rule with the help of some examples. Suppose we have a function e raised to power x square. How are we going to differentiate this function? Finding the derivative of y is same as finding the derivative of e in terms of x square. Because the derivative of exponent function is the function itself, the answer is e raised to power x square multiply with it the function, the derivative of the power, which is function x square. The derivative of x square is 2x, so the answer is 2x times e raised to power x square. Let's have another example where the function is 5x plus 1 raised to power 20. If you want to differentiate this function, the derivative is going to be the derivative of this function as a power function. We may assume that it is equal to u raised to power 20, where u is 5x plus 1. So the power rule will be applied first. The answer is going to be 20 times 5x plus 1's power 19 multiply with it the derivative of 5x plus 1, which is 5. So the answer is 5 into this product, this function, which is 100 into 5x plus 1 raised to power 19. Let's have some more examples. Let's say the function is ln 10x. The derivative of this function is going to be the derivative of ln u, where u is 10x. So derivative of ln function is 1 over the function, that is 10x here, then the derivative of 10x, which is sec square x. So the answer here is 1 over 10x into sec square x. Although 10x is 1 over 10x is cot x or cos x over sin x, while sec x is 1 over sec square x is 1 over cos square x. So eventually you may end up getting 1 over sin x cos x can be expressed as sec x cosec x. So that is one of the possible answer of this particular function. Let's have another example. Suppose the function is e raised to power sin x. The derivative of this function is going to be the derivative of the exponent function is the function itself. So it is e raised to power sin x multiply with it the derivative of that power, which is derivative of sin x. The derivative of sin x is cos x. So the answer is cos x into e raised to power sin x. In fact, we can generalize some of the functions. Suppose if we have y equals to ax plus b raised to power n, the derivative is according to chain rule n times ax plus b raised to power n minus 1 into derivative of ax plus b. So it will eventually be n times a into ax plus b's power n minus 1. It can be used as a formula. If the function is e raised to power ax plus b, then according to chain rule, the derivative is always be a times e raised to power ax plus b. So these two can be used as formulas, and many more functions can be generalized in the same manner. Suppose we have y equals to fx having a power n, so the power rule always be applicable. So the derivative here is going to be n times fx raised to power n minus 1 times the derivative of that function.